Okay, so let's talk about more kinematics. Let's talk about more kinematics. So what do we have here? We have a particle that is moving. Okay, here's our little particle. It's a little car, and it's moving, and it has a displacement. Okay, this is the displacement. Okay, let's call it delta x. And it starts to move from rest. So the initial velocity is going to be 0 because it starts from rest. And it's moving with constant acceleration. And the constant acceleration is going to be 2 meters per second square. And it starts to move from x of naught equal to 0, which is the initial position. And we're going to do a graph for the times going to be 1, 2, and 3 seconds. So let's see how this looks like. Okay, so we know that delta x is equal to VOT plus 1/2 of AT squared. And this is for a particle that moves in one dimension, because this guy is moving in one dimension. And with constant acceleration, which is 2 meters per second square, we have that x minus x of naught is going to be VOT plus 1/2 AT to the square, where A is the acceleration. And in this case, this is going to be 0 x of naught, because he starts to move from the initial position x of naught equals 0. And the initial velocity is also going to be 0 because he starts to move from rest. Okay, so x is going to be 1/2 of AT squared. And this equation is going to give you the position of your particle. Okay, so let's do it for 1 second. For 1 second, it's going to be 1/2, and it's going to be 2 meters per second square, which is your acceleration. 1 second elevated to the square. So that's going to be equal to 2/2 meters over second square times 1 second to the square. And you can cancel the squares and you get here 1 meter. Okay, let's do it for 2 seconds. For 2 seconds, it's going to be 1/2, 2 meters over second square, which is your constant acceleration. It's 2 seconds, but you got to elevate it to the square. So it's going to be 2/2 meters over second square times 4 seconds to the square. So you cancel second square with second square, and this is going to be 4 meters. So there you go. Everything is looking good. Let's do it for 3. So it's going to be for 3 seconds. It's going to be 1/2, 2 meters over second square times 3 seconds, but seconds elevated to the square. So it's going to be 2/2 meters over second square times 9 seconds to the square. And you cancel seconds to the square with seconds to the square. And this is going to be 9 meters. So what do we have here? So we have our, well, I'll do it over here. We have x, and we have the time, and we have for 1 second, we have, this is in seconds. For 1 second, we have 1 meter. This is in meters. Let's put meters right here. So for 2 seconds, we have 4 meters, and for 3 seconds, we have 9 meters. So we can do a graph of this. So the graph is going to look like this. Here is your graph of how this is going to look. So we're going to give it some color here. So this would be the time, and this would be the position. So it's going to be 1, 2, and 3. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be all the way over here. So it's going to be 1 and 1. So it's going to be right here. and it's going to be 2 and 4. 1, 2, 3, 1, 2, 3, 4 over here. Okay, right there. And it's going to be 1, 2, 3, 4. Yeah, that's correct, right here. And then it's going to be 3 and 9. Okay, so it's going to be 3 and 9. It's going to be over here, 3 and 9. And look, what do we get here? So what do we have now? We have a parabola that goes this way. Okay, let's make the parabola right there. Something like that. So it should look like a parabola. So this is the graph of x versus time. And that gives you the graph of the position. So this is the position versus time. Okay. And we could do another one for the velocity. So let's do the one for the velocity. So let me get rid of this. Let's clear this one. And now we have the acceleration. We said that our it's 2 meters per second square. And we are going to do this for times 1, 2, and 3 seconds. Okay, no problem there. So the final velocity is equal to the initial velocity plus AT. But we said that the initial velocity is going to be 0 because your particle starts to move from rest. So this guy goes to 0. So the final velocity is going to be acceleration, which is 2 meters per second square and multiply by the time. Okay, let's do it for 1 second. So it's going to be 2 meters per second square, and then you multiply by 1 second. So this is going to be 2, and this cancels with the square, 2 meters per second, and you got your first velocity. So let's do it for 2 seconds. So it's going to be 2 meters over second square times 2 seconds, and second cancels with the square, so it's going to be 4 meters, okay, over second, 4 meters over second. And let's do it for 3. Okay, so it's going to be 2 meters over second square, which is your acceleration, and it's going to be 3 seconds. So it's going to be, second is going to cancel with the square, and this is going to be 6 meters over second. Okay, so you got a graph of the velocity against time. For 1 second, your velocity is going to be 2. For 2 seconds, your velocity is going to be 4. And for 3 seconds, your velocity is going to be 6. And we can make another graph here. Let's do another graph. So the graph is going to look something like this. Okay. So we have here the time. We have the time right here. So this is going to be the time. Okay. Yeah, I don't like this one here. This is going to be the time. And we have the velocity. And we have 1, 2, 3 seconds. And we have 1, 2, 3, 4, 5, 6. So what do we have here? We have that for 1 is 2. For 1 is 2 would be right here. And then for 2 is 4. So 1, 2, 3, 4 over here. There you go, right there. And for 3 is 6. 1, 2, 3, 4, 5, 6 over here. For 3, you go all this way here. Okay. And you got your graph right here. It's supposed to be a straight line. There you go. So this is the graph of the velocity versus time. And it's a linear linear relation. Okay, and let's do it for acceleration, but acceleration is going to be equal to 2 meters per second square all the time. So that graph is going to look like this. We're going to do that graph here. So we have for time, we have time against acceleration. So it's going to be 2 meters per second square. And you got 1, 2, and 3 seconds. So your acceleration is going to look something like, it's going to be the same here. It's going to be the same here. And it's going to be the same over here. So your acceleration is going to look something like this. So there's no slope there. Okay, no slope. And we have the 3 graphs. This is for a particle that's moving with constant acceleration, and that starts to move from rest. So the initial velocity is going to be 0. And we have done the graphs for the position, for the velocity, and for the acceleration. So this is position, velocity, acceleration. As you can see, you got a parabola, you got a line, and you got no slope in the third one. Okay, so thank you, and we'll continue next time.